few more people. There's still a few more people trickling in, but let's start out. Good afternoon, everyone, and welcome. My name is Bill Chambers, and I will moderate the session. And I'm going to keep it real short just to say that I am a longtime analyst here at USDA, and we are very excited to have you all here. This is the breakout session on the Western drought. And this session will follow the same format as the other sessions. So please leave your questions in the Q&A, and I will direct them to the appropriate panel member. I may take a few questions between the speakers, but I'll save most of them for the end, except Brad Pugh has to leave a little early, so we may take a special note of that and get some questions for him. We have 3 distinguished speakers here today, and in the interest of time, I'm going to hand it off to Brad, and I'm going to let our speakers introduce themselves. They have graciously agreed to that. So go ahead, Brad.
Yeah, thank you, Bill. I'm Brad Pugh, meteorologist at the Climate Prediction Center, one of the U.S. Drought Monitor authors, and also seasonal drought forecasters. So, thanks for the opportunity to present some information on our seasonal drought outlooks today. So with that, I guess I'll go ahead and get started.
There we go.
All right, so starting off here, just with a kind of a timeline of our drought outlooks. The seasonal drought outlook began more than 20 years ago, shortly after the U.S. Drought Monitor became operational. Our seasonal drought outlook is released each month, third Thursday of the month. And starting 8 years ago, a monthly drought outlook was released at the end of the month to help capture rapidly developing drought. The intent of the seasonal and monthly drought outlooks are to present a simple national picture of where droughts will improve, persist, or develop. Here's the latest monthly drought outlook, valid for September, that was released at the end of August, which shows during September we were expecting development across the Southern Plains. They actually verified quite well, had a kind of a short-lived rapid development of drought there over the Southern Plains during September. Next slide here is the seasonal drought outlook that was released back in August, valid for mid-September through the end of December. And with the onset of La Nina and the likely continuation of La Nina through the winter, we are expecting an expansion of drought across the Southwest, including the Southern Plains. Most likely area for improvement would be the Pacific Northwest, which tends to be wetter during a La Nina. So what goes into the creation of our drought outlooks? We start with the most current U.S. Drought Monitor conditions. So we use the D1 or higher drought shapes here as a base, and then predict where those areas will either improve or persist. And in terms of forecasting inputs, those include the short-term time scale, less than 1 month, the longer range forecast tools, 1 to 3 months, and then climatology is a very important tool, depending on if a season is either wet or dry. So for example, the Pacific Northwest, we're going to a wet time of year. So climatology alone would favor improving drought conditions for the Pacific Northwest. Here here are examples of the short-term tools, including the Weather Prediction Center 5-day precipitation forecast, the Climate Prediction Center's 6 to 10 and 8 to 14-day precipitation and temperature outlooks. And the longer-term tools include our seasonal temperature and precipitation outlooks, also dynamical models, composites for La Nina or El Nino, depending on the state of ENSO, and also decadal trends in temperature and precipitation. So circling back here to climatology, when we don't really have a strong signal among the models or ENSO composites, we really lean on climatology for guidance. As I mentioned, for the West Coast, heading into the winter, that's a wet time of year, so that would tend to favor drought improvement. Conversely, over the plains, December, January, February, that's a dry time of year. So if you do have ongoing drought, it's likely to persist during the winter, just due to the fact that it's a relatively dry time of year, especially for the northern plains. So I won't go through all this. Yeah, it's kind of a busy graphic and shows kind of the different steps in the drought outlook production. But we do receive lots of feedback. It's an iterative process with feedback from stakeholders, and we do have a briefing as well. But yeah, I just wanted to kind of stress this last point here that observations that go into the model forecast, ENSO composites and climatology are a strong foundation for a more accurate drought outlook. And just real quick, I just have a few minutes here left. Just want to show some ongoing work here. We're at the Climate Prediction Center. We're planning to introduce a flash drought to our week 2 hazards product. Hopefully that will be implemented by next growing season, so next spring. Yeah, we want to apply the tools and methodology used for development forecast and the monthly drought outlook to the week 2 hazards to help identify areas of flash drought when conditions warrant. The second bullet's real important. Yeah, we want to take advantage of skillful temperature forecast in the 1 to 2 week time span, and help improve the communication of flash drought risk later in the month. And the inputs to the flash drought tool are pretty simple. We include initial conditions, and then just week 1 and week 2 temperature and precipitation forecast. So it's a pretty simple method, and we'll obviously use other tools as well in pinpointing these likely areas for flash drought. And here's just a sample of the output from this flash drought tool. Back at the beginning of July, it was targeting areas of the north central US. It's actually verified pretty well. We had either intensifying or expanding drought across many of these areas, including Nebraska and Montana. And that's all I have. So yeah, thanks for your attention.
All right, thanks, Brad. We don't have any questions in the chat box yet. So as you guys get questions, feel free to drop them in there. But for now, we're going to move on to David.
All right, thank you. All right, can you see my screen?
Yep.
Okay, great.
Looking good.
Okay, I'm Dave Summerall from the Western Regional Climate Center and Desert Research Institute in Reno, Nevada. I'm a climatologist there and a U.S. Drought Monitor author, along with Brad. I made a few tweaks, so if you have my presentation, there may be a few differences, but they'll be small. I have quite a bit to cover here, so I'm gonna go get started here. So looking at the current conditions, drought conditions, actually a new map came out today, but I didn't update that, but probably not a lot of change. So we've got about half the country that's currently in drought. The Western United States, where I'm going to focus on today, you can see is 90% in drought, with about 53% in D3 to D4, the two most severe categories. Something notable this summer was that by late July, we hit the highest percentage area of drought for the Western US since the Drought Monitor began in 2000, as well as the highest percent area of D3, D4 in the Western US. As you can see, under the impacts, we're seeing the full spectrum of drought-related impacts across the Western US. We have seen some significant improvement in conditions, mainly in the Four Corners states during the summer of 2021, this past summer, due to the record to near record breaking monsoon precipitation in some of those areas. And I'll talk a bit about that more. This is looking at the, these are a couple products from the West-wide Drought Tracker that's created here at the Western Regional Climate Center on the left. This is looking at mean temperature for the last water year, so October 2020 to September 2021, and these are percentile rankings. So you can see all the warm colors represent above normal temperatures, and you can see we've got a lot of record-breaking temperatures, average temperatures for this period in California, Nevada, also in areas of Arizona. On the right, this is looking at precipitation. And again, you can see over the past year where the drought is most intense now, we have record dry conditions across areas of California, as well as the Great Basin, areas of the Northern Rockies of Idaho, as well as on the Columbia Plateau in Washington State. These are change maps from the US Drought Monitor, and I picked a couple different periods to look at. On the right, we'll look at first, this is comparing 1 year ago. So basically this is looking at the October 6, 2020 map as compared to where we are now. And the warm colors represent degradations and conditions, while the cooler colors represent improvements. And you can see we've had in the past year, comparatively, a lot of degradation along the West Coast in California, as well as in the Pacific Northwest in Montana, while the improvement has been focused on primarily in the Four Corners states due to the monsoon season, as well as some wet spring conditions in the eastern plains of Colorado. Looking at the 3 months, so this is looking towards the beginning of the monsoon season, we've seen quite a bit of improvement in Arizona, as well as in parts of Utah, western Colorado, and New Mexico, while the deterioration has mainly occurred up in the Pacific Northwest, as well as areas of California. Looking at reservoir storage statewide, as you can see, this is the latest from NRCS. A couple of the states haven't reported yet, but we're pretty much below normal. And this is, granted, this is a low time of year coming into the cool season. However, we are below normal across all states in the West, except for Washington, and I believe Montana should be right about normal. Looking at the Colorado River Basin, focus on the two largest reservoirs in the Western US, Lake Mead and Powell. Those are at record level in terms of Lake Mead. It's about 35% full. Powell's about 30% full. One thing that we're really keeping an eye on with Lake Powell is the power generation from Glen Canyon Dam, and some projections are showing that it may reach this dead pool elevation where they will not be able to generate power possibly in 2022. In response, Bureau of Rec has been doing some releases from reservoirs up above to bolster the levels at Lake Powell. Total system-wide, you can see 38% full. We're about down 10% from the previous year. These low levels have triggered a tier 1 water shortage declaration, which is the first time this has ever occurred from a federal level. And this is going to impact in 2022 water users, the junior water users in Nevada and Arizona, and they're going to have about a 20% reduction. This is mainly going to hit agricultural users in Arizona. California, pretty poor situation there as well. Both of the largest reservoirs in the state are at 22% full, with Oroville so low that it stopped power generation in July. And looking over in the Rio Grande, the largest reservoir in that system is 6% full. Looking at the drought development, much of the drought was the current drought situation. The West was drought free coming into spring of 2020. And you can see here's a drought monitor map in the upper left from April 7th. And this is about time of the peak snowpack levels in 2020 or in general, but this is in 2020. So you can see I've circled areas that we had some lingering long-term drought coming into the summer months in 2020. As things progress in the Southwest, things really ramped up because of the poor monsoon season, which was the driest on June through September on record in the Four Corners states, as well as we had record heat across the region as well during that summer, and a poor snowpack. California and Great Basin had a little different story. Most of the intensification occurred this springtime, moving into summer. And that's because of back-to-back dry snow years, as well as early meltdown and poor runoff, and anomalously warm temperatures this past summer. Pacific Northwest, things intensified during the spring months this year due to below normal precipitation during the spring, as well as early summer. But then we had the record heat moving in to the summer months. And as most of you probably saw in the news, areas of the Pacific Northwest were very warm with, I think Portland hit 116 degrees, and that's an all-time record high. I'm going to move on. And so looking at big picture of the drought in the West to give some perspective. So basically the current situation sits within a backdrop of about 2 decades of drought in areas of the West. Here are a couple on the left, a couple time series graphs of on top is precipitation, bottom temperature. These are 24-month periods ending in August because we don't have the September data yet. This is looking at everywhere west of the Rockies. And as you can see, we hit for the 24-month period, we had the driest on record that period, dating all the way back to 1900. And then looking at temperature, same thing, you can see this trend. It wasn't as hot as some previous years overall, but what you can see is this trend is notable. And this is starting in basically in the late 80s and into 90s and 2000s, this warming trend. Looking at another metric, this is upper right, looking at the Western US percent of area that's either wet or dry. And this is using the Palmer index. And you can see we hit a record in the 122-year record this year with nearly 100% of the West that was experiencing moderate to extreme drought conditions. And then on the bottom right, this is a Haywood plot, and I chose this for the upper Colorado River Basin because this is where they're experiencing We've had a lot of problems in terms of reservoir storage in the Colorado River system with Meade and Powell. And what you see here is on the x-axis on the bottom, this is tracking precipitation throughout the water year. So this is October, moving to where we are now at the end of the water year. And you can see the 5 wettest years are the cool colors on the top, and here are the dates. And then the 5 driest. And what's notable to me in this region is 3 of the high or driest years occurred within the last decade. And this year we're a little bit above that. And I think that's basically related to the monsoon season in those states, which drove that up, out of the top 5 driest. This is looking at snow and snow drought. And snow drought's a term that we've been using in the drought monitoring and community over the past 10 years. And so basically it's defined as below average snowpack at a given point in time, typically April 1st. And that's usually when the snowpack is at its maximum. And there's 2 types of snow drought. There's warm snow drought, which is a lack of accumulation despite near normal precip caused by warm temperatures and precipitation falling as rain rather than snow or unusually early snow melt. And dry snow drought is basically just below normal cold season precipitation. So looking at these 2 maps here on the left, this is at that maximum point where the SWE is at its highest on April 1st. So this is 2020. And so under neutral conditions, and you can see the warmer colors these are the SNOTEL snow monitoring stations that the NRCS has. And the ones in the warmer colors are below normal. And you can see those across the Sierras, the Klamath Mountains in Northern California, as well as in the Klamath Basin in southwestern Oregon, areas of Idaho, and down along the Mogollon Rim and in New Mexico. And what I wanted to point out was an example of the warm snow drought. You can see down on the Mogollon Rim, we had really low snowpack on April 1st. In some areas, it was just gone. But as you can see in the circle here, this is water year-to-date precipitation. So that includes rain and snowfall up to that same date. And you can see those were near normal to above normal. Looking on the right, this is 2021, this past year. And as you can see, California, again, another dry snow year in the Sierras, as well as parts of the Klamath Basin, up in the Wasatch Front, as well as the Uinta Mountains, southern Idaho, and western Colorado. Kind of a mixed bag down in the areas of the Southwest. And talking about snow drought and this early melt out, this has been one of the major issues during the past 2 years, is the impact of the above normal temperatures on basically the snowpack melting out prematurely during the winter time or in the spring months. And I wanted to show you one example. This is from a SNOTEL station at Squaw Valley, California, which is around Lake Tahoe. And that's the graph on the right. And this is looking at snow water equivalent, tracing it through the water year. On the left, I chose to represent the temperatures. This is from South Lake Tahoe Airport, from a weather service station there. And as you can see, I put a circle around these temperatures during the spring months. So this is when spring, or the snowpack's at its maximum, and we get the spring melt out and runoff occurring. Red areas are above normal temperatures based on the climatology. And you can see this is last spring. We had a lot of above normal to near or record temperatures during that period. And now you can see that over on the snowpack, tracing that through the year. So for example, the black line is 2021, and you can see this, basically it wasn't the lowest snowpack on record, but it was pretty darn close to it. And you can see the date I have on the bottom is the date in which the snowpack was completely melted out. And that was on May 9th. And the median over the whole period of record, it generally melts out on June 8th. So that's a month early, and that has big repercussions when this is happening over a mountain range in terms of runoff and reservoir storage. And just one last slide on the snow drought issue, because this is a major issue with the drought and changing climate in the West. This is based on some research looking at precipitation phase partitioning. So on the left, basically what we're looking at here in general, I'm going to look at the Sierra Nevada range. And you can see these are different month periods and what percentage of precipitation is falling as snow. So the pink areas, the deep color pink or purple, are areas where it's 100% snow. And those are generally on the southern end of the Sierras. If you're not familiar, that's where the highest peaks are in the range, ranging from 10 to 14,000 feet. But what's notable on the bottom, and we're going to go backwards on it, but if you look at the water year of 1980, and you look at how much purple is there, so you're seeing a higher percentage of during the water year of the precipitation that's falling as snow. And then moving into 2008 and 2015, you can see there's less and less of that purple area. And basically what you're seeing is more that's falling as rain, especially in these lower elevation areas. And on the right, we're looking at change in percentage of snow during different time periods. And I want to focus on looking at the March through April period and these shoulder seasons and these warmer temperatures we're experiencing. And you can see how much change that we're seeing in the snowpack during that period. Some of the challenges we've faced as drought monitor authors and others assessing drought, snow drought issue, which I just covered. Also the rapid expansion and intensification of drought in areas of the West during the spring. I think something that the models had some difficulty picking up, and it was a difficult part of doing some of the drought monitoring, is the impact of the 2020 dryness in areas of the Southwest and other areas of the West, and that record-breaking heat and how it really desiccated the vegetation as well as the soils moving into the winter months. And having a dry winter in terms of precipitation and snowpack, basically the soils soaked up a lot of the snowpack, and a lot of it went to the atmosphere. The snowpack, that is, evaporated or sublimated to the atmosphere, and we had really low runoff this past year. Another issue was the short-term versus long-term drought, and the impact of the monsoon season this year, which was well above normal in parts of the West and the Southwest. And how much impact does that have in balancing, making improvements on the drought monitor map and keeping those, taking those long-term effects into account. And looking at the last one, this is a really interesting one, the ecological drought, and we still don't know a whole lot about some of the impacts of the ecological drought and the longer impacts. But what we do know is this long-term stress from the drought over the last decade in the Sierras and other parts of the West. And if you look on the right, bottom right, these are the number of dead trees in California, and these are based on aerial surveys by the U.S. Forest Service. And this is a cumulative line of from the years of the surveys, and you can see there's about 160 million dead trees in California. And the map on the left shows you the percentage of trees that died in those particular areas during that time. And this is really significant. And I think this has a huge impact on the energy balance at the surface and runoff and so forth. So that's an interesting area. Coming to a close here in a couple slides. This is looking at a drought monitor map, and as drought monitor authors, these are some of the data tools that we use that are available to the public as well in making our assessments. And we use an approach called, basically we're looking at a variety of different indicators at differing time frames. And this is our convergence of evidence approach. So I'm just going to quickly go around clockwise here and look at a few of these So basically, we've got in the upper right things like PDSI and SPI. In soil moisture, we've got some new products that have come out by the USDA, working with NASA. And this is a new product that came out recently. And then we have EDDI, which is an evaporative demand product. The USGS stream flow percentiles we look at, some remote sensing products like NDVI, looks at greenness indicators. We have our expert local input, which is key to our monitoring, and we're working closely with drought monitoring coordination groups around the West, and then the snowpack data and precipitation data. And then these are just some examples of the specific products that are used and used in the West. And some of these are weighted more heavily during certain times of the season and so forth. One that is coming out in the next week that I think is of real interest in terms of agriculture is OpenET. And this has been created by some folks here at the Desert Research Institute, as well as working with USDA, ARS, and some other groups. And this is based on remote sensing, Landsat, and MODIS imagery. But basically, you can click on a farmer's field, and this is based on 25 years of 30 years of satellite imagery, as well as ET modeling. But you can click on a particular field, and it will give you a time series of ET, water loss by ET within a year. And I think this is a really neat product that's going to be helpful towards a lot of folks in the ag community. And this is my final slide. This is actually a hedgehog cactus that I took a photo of this summer in Walnut Canyon National Monument in northern Arizona. And I look at a lot of these things while I'm out. I love vegetation and looking at things, but you can see the desiccation that's occurring on these cactuses, which are really robust. And this, to me, tells you something about the long-term impacts of the drought and the lack of precipitation. All right.
All right, David, thank you very much. Benjamin Diamond has a question on ag-specific uses, but I'm going to let you answer that in the chat if you could, and I'm going to send it straight over to Mark Brusberg. Mark, if you could take it away.
Okay. Can you? All right, great. I got it. Okay. Can everybody see my screen?
Yep, looks good.
Okay, well, I'm Mark Brusberg. I'm the chief meteorologist at the USDA's Office of the Chief Economist and the World Ag Outlook Board. I'm one of the 5 meteorologists that Dr. Jakanowski mentioned yesterday as contributing to the WASDE report. And I spoke earlier this year on that process. Now, what I'd like to do today is talk about the Western drought. And it's no surprise that the West is having a drought of historic proportions, but I wanted to sort of put that in the context of what we're going to have to do to address these droughts in the future. Now, the drought is basically a convergence of 3 things. There are natural cycles. And again, I'm not going to take a lot of time. We're getting close to the end of the session, but you can have these charts and investigate these on your own. But through climate research, mega droughts or droughts lasting more than decades have been identified in the West going back more than 1,000 years. Thankfully, they're rare, but they are a part of the natural occurring cycles. There's also the warming that Dave Simmerall just talked about. You heard the phenomenon of snow drought. That's because we've seen warmer conditions over the past few decades, which is referenced on the left-hand side. And on the right-hand side is the IPCC projection of continued warming. So that's not going to get any better. We also have increasing competition for the water supplies. But it's more than just more farmers, more people drinking water. Each reservoir, each watershed is providing drinking water and water for industrial purposes, for farming, for electrical generation. And just briefly, as Dave also pointed out, we're seeing restrictions for the first time in the history of some of these reservoirs. Right now, because of the low levels on Lake Mead, allocations have been reduced to states, and electrical generation has been reduced. And reservoirs, water managers, water districts throughout the West are having to make tough decisions on who gets water and who's going to have it in the future. Now, the bottom line is everybody is going to have to work together to make sure that the entire community has water. Now, earlier this year, using the Klamath River Basin as an example, earlier this year in April, USDA allocated $10 million to producers because they knew that they were not going to get the water needed. Now, some of that went towards planting a cover crop, but so that there was not going to be wind erosion as the drought continued. But just, put yourselves in the place of a Western farmer who doesn't know from one year to the next whether he or she is going to get enough water to farm that year. And it's pretty sobering thought. And when you consider that some of the mega droughts in history actually coincided with losses of indigenous culture, these are game-changing, for lack of a better word, events. And this is something that is going to be part of the Western future. Now, there has been a renewed focus, renewed directives for looking at drought in terms of making the country resilient. Both the White House and Secretary Vilsack, and really we've been trying to do this for decades. We can't keep responding to drought as a one-off like it's just any other disaster that can be recovered from. This is something that is going to change the way a lot of people do business, especially in the Western United States. Now, this is a chart that I borrowed/stole from FEMA. This is their disaster recovery framework. And again, I'm not going to take a lot of time because you'll have these links to investigate. But even with a disaster like a hurricane, an earthquake, etc., there is preparedness. Not only is there relief, but through that relief, the months and years of long-term rebuilding, lessons are learned, okay? And those are the type of lessons that we're now learning for the West, okay? People have to have a drought plan. They have to know how to manage risk. And they have to leverage conservation programs, whether it be something like CRP, where they're setting aside part of their land in the event there's a drought and they need that forage, to maybe doing things like, in some of the wetter parts of the United States, putting in drainage tiling. And that's basically, and again, I went rather quickly, but again, there's my contact information, but I just wanted to maybe introduce the concept, if it already hasn't been, that what we're seeing in the West is going to impact the future of American farming, because now we know how severe a drought can be. We know that droughts are expected, and we know that we are again, for lack of a better term, we're competing for every drop of water in the West, be it people wanting to farm, electricity producers, or people just wanting drinking water and for hygiene. So I will stop there. And again, I wish I had a little more time, but here are the charts. There's my contact information. Please reach out to me if you have any questions. And again, thank you all for the organizers for offering me this opportunity to speak to everybody today. Thank you, and I will stop sharing.
All right, thanks a lot, Mark. That was very interesting, and thanks to all our presenters. those were very interesting. We had a couple of questions, but both were answered in the chats. And we are coming up to the end of our time. So I just want to make sure there aren't any final questions for the presenters. If not, I got a thank you. Well, that's excellent. We got some thank yous. Got some thank yous with exclamation points, so that's extra special. But again, thank you everybody. It was very, very interesting and very important issue, and it was a great session. I appreciate it. I'm calling the session over, I guess.